Hello, welcome to CREATA Classes. I am Gurmeet Singh and also welcome to our new series on Class 10th Chapter 9, Some Applications of the Trigonometry. And in this series, we will cover all these lectures using the power of visualization. Hope you will love our new way of teaching and the creative way of teaching. And apart from this lecture series, we also have a quiz and the PDF of the concept and formula list. Check the link in the description. And especially in this lecture, we will cover the NCERT exercise 9.1, question number 11 to question number 15. And again, do not underestimate the NCERT example questions. They are really good. Okay. So without taking any further time, let's start with this lecture. Best of luck, and here is the lecture. Let's take question number 11. A TV tower stands vertically on a bank of a canal. From a point on the other bank directly opposite the tower, the angle of elevation of the top of the tower is 60 degrees. From another point 20 meters away from this point, on the line joining the point to the foot of the tower, the angle of elevation of the top of the tower is 30 degrees. Find the height of the tower and the width of the canal. So this is the question. Firstly, let's observe the question. A TV tower is given. This is a TV tower and this tower stands vertically on a bank of a canal. So this is a canal and this is the tower. From a point on the opposite bank of the canal, the angle of elevation of the top of the tower is given. It means we are having a point on the opposite bank of the canal, and from this point we are looking at the top of the tower, and the angle of elevation formed is 60 degrees. Angle of elevation when we are looking upward, and this is with respect to the horizontal line. So this angle is 60 degrees. Further, another point is also given which is 20 meters away from this point. So this is the point which is 20 meters from the first point, and from this point also the angle of elevation is given to the top of the tower. It means from this point also we are looking at the top of the tower, and the angle of elevation or the angle formed is 30 degrees. So two angle of elevation are given from two different points. The distance between the 2 points is 20 meters. The first angle of elevation is 60 degrees and the second angle of elevation is 30 degrees. The 4 points are A, B, C and D. And in this question we have to find the height of the tower and the width of the canal. Height of the tower is the distance AB and the width of the canal is the distance BC. It means we have to calculate AB and BC in the given figure. So this is the scenario that is given in the question. Let's apply the trigonometry in the given figure. Are you able to observe the two right angle triangle in the given figure? The first triangle is triangle ABC, which is having the trigonometric angle as 60 degree angle. And the second triangle is the triangle ABD, which is having the trigonometric angle as 30 degree. So let's apply the trigonometric ratio formula in both the triangles. Firstly, let's take the right angle triangle ACB. For this triangle, AB is the perpendicular which is opposite to our trigonometric angle 60 degree, and BC is the base for this triangle. And AB is the height of the tower and BC is the width of the canal that we have to find. So here perpendicular and base are coming into the picture. So our trigonometric ratio tan theta will be applicable. Tan theta is a relation between the perpendicular and base. So we got tan theta is equal to perpendicular upon base. We got tan 60 degree is equal to AB upon BC. And what is the value of tan 60 degree? Tan 60 degree is root 3. On solving, we got AB is equal to BC root 3. So this is the equation. Let's keep this equation on the side. We will use it later on. Further, let's take the right angle triangle ADB. Here AB is the perpendicular and BD is the base of this triangle. Got it? AB is perpendicular as it is opposite to our trigonometric angle 30 degree, and BD is the base for this triangle. Again, base and perpendicular are coming into the picture. So which trigonometric ratio will be applicable? Again, tan theta will be applicable, which is equal to perpendicular upon base. So tan 30 degree will be equal to AB upon BD. And what is the value of tan 30 degree? It is 1 upon root 3. Got it? Further, we got the value of AB, that is the height of the tower, as BD upon root 3. In the first triangle, we got AB as BC root 3. In the second triangle, we got AB as BD upon root 3. Both are the value of AB, so we can equate both the equation. We got BC root 3 is equal to BD upon root 3. So on solving, we got 3BC is equal to BD. And if you observe in the given figure, BD is the complete distance. This complete distance which is composed of DC and CB. Got it? BD, the complete distance, is equal to DC and CB. So we can replace BD with DC and CB. And DC is given as 20 meter in the question. So we got 3BC is equal to BC plus 20. Only the variable in this equation is BC. So let's solve for BC. On solving, we got BC as 10 meter. And what is BC? BC is the width of the canal. So one part of the question we have done, that is we got the width of the canal as equal to 10 meter. Now let's move to the second part of the question, that is finding the height of the tower AB. And in the first triangle we have got AB as BC root 3, and just now we got BC as 10 meter. So on solving, we got AB as 10 root 3 meter. That is the answer, that is the height of the tower. So we have done with the question. We got the width of the canal as 10 meter and the height of the tower as 10 root 3 meter. Got it? The more you are able to visualize the question, the more easily you will be able to solve the question. Understand the power of visualization. Very interesting. So we have done with this question. Let's move to question number 12. Question number 12. From the top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 degree and the angle of depression of its foot is 45 degree. Determine the height of the tower. So this is the question. Let's observe the question. This question is talking about two angles, the angle of elevation and the angle of depression. Angle of elevation when we are looking upward and angle of depression when we are looking downward. And both of these angles are with respect to the horizontal line. The common mistake done by the student is that they take these angles with respect to the vertical lines. Don't do this mistake, don't be confused. Both of these angles are with respect to the horizontal line. Angle of elevation when we are looking upward, angle of depression when we are looking downward. So these are the basic concepts that will be used. So let's observe what is given in the question. In this question, a 7-meter high building is given. So let's take this building, and also a cable tower is given whose height we have to calculate. From the top of the building, we are looking at the top of the tower and also at the foot of the tower. When we are looking at the top of the tower, the angle formed is angle of elevation. When we are looking downward to the foot of the tower, the angle formed is angle of depression. And both of these angles are with respect to the horizontal line. The angle of elevation is given as 60 degree and the angle of depression is given as 45 degree. Note that here both of these angles we are taken with respect to the horizontal line. And in this question we have to find the height of the complete cable tower. Let's take the points as A, B, C, D and E. AB is the height of the building which is given as 7 meter and EC is the height of the cable tower which we have to calculate in this question. So this is a scenario that is given in the question. So let's approach this question. Are you able to observe the two right angle triangle? Yes, these are the two right angle triangle in the given figure. The triangle ADE and the triangle ADC. And for the triangle ADE, the trigonometric angle is 60 degree, and for the triangle ADC, the trigonometric angle is 45 degree. In this question, we have to find the complete height of the tower, that is EC. If you observe, the height of the tower EC is composed of two components, ED and DC. ED belongs to the first triangle and DC belongs to the second triangle. Further here, AB, the height of the building is given as 7 meter. And here AD and DC both are equal to each other. Here AD and BC, these two lines are horizontal lines and are parallel to each other. So AB and CD, the distance between these two lines will be equal. So we got DC, that is one component of the tower, we got DC as 7 meter. Only we have to calculate the distance ED to find the complete height of the tower. So basically in this question we only have to find the distance ED. And if you take the triangle ADE, the only thing that we know about this triangle is the trigonometric angle 60 degree. We do not know any of the three sides. So we cannot proceed with the trigonometric ratio for this triangle. We should know any of the one side and the trigonometric angle to find the rest of the missing dimensions of that triangle. Got it? The point that we have discussed in the theory part. Once we know one angle and any of the one side, we can find anything about that triangle using the trigonometric ratios formula. So we need any of the one side to further proceed with the trigonometric ratios for this triangle. For that, we will take the help of the triangle ADC, in which one side, that is DC, is given as 7 meter and the trigonometric angle is given as 45 degree. So once we got the trigonometric angle and any of the one side, we can find the missing dimensions of the triangle. So firstly, let's take the triangle ADC and apply the trigonometric ratios. Before that, let's identify the trigonometric sides. That is important because here our triangle is inverted. Firstly, perpendicular. Perpendicular is the side which is opposite to trigonometric angle. So here our trigonometric angle is 45 degree. So the side CD is the opposite to 45 degree angle. So CD is the perpendicular for this case. And what about base? Base is the side which is between the trigonometric angle and the 90 degree angle. So the side AD is the base for this triangle. So what is the trigonometric relation which links the perpendicular with the base? It is tan theta, right? It is tan theta which is perpendicular upon base. So tan 45 degree will be equal to DC upon AD. And DC it is given as 7 meter. And what is the value of tan 45 degree? It is 1. Tan 45 degree is equal to 1. The interesting case that we have already discussed. So we got 1 is equal to 7 upon AD. So we got AD as 7 meter. In case of 45 degree angle, the perpendicular and the base both are equal to each other. So here base is equal to perpendicular. So base and perpendicular both are equal to 7 meter. Further, we got the side AD and the side AD is common in both the triangle. So for the triangle ADA, this triangle, here AD will be equal to 7 meter. So we got one of the side of this triangle and the trigonometric angle we already know. So we got the trigonometric angle and the one side. Now we can find any of the missing dimension. So let's proceed. Here AD is the perpendicular as it is opposite to our trigonometric angle 60 degree. And AD is the base which is between the trigonometric angle and the 90 degree angle. So let's apply tan theta which is perpendicular upon base. Tan 60 degree will be equal to ED upon AD. And here AD we have just calculated as 7 meter. And what is the value of tan 60 degree? Think it is root 3, right? So we got root 3 is equal to ED upon 7. So we got ED as 7 root 3. Got it? We got the perpendicular, that is ED, one component of the tower ED as 7 root 3 meters. So let's find the complete height of the tower EC, which is equal to ED plus DC. ED we have calculated as 7 root 3 and DC we know it is 7 meter. So we got the complete height of the tower as 7 root 3 plus 7, which is 7 into root 3 plus 1 meters. That is the answer of the question. Got it? The better you are able to visualize the question, the better you are able to solve the question. So for especially the trigonometric question, pay special attention to what is given in the question. The rest, applying the trigonometric ratio formula, is very simple. Majority of the time spent in identifying what is given in the question and identifying the right angle triangle in the given scenario. Got it? So we have done with this question. Let's move to question number 13. Question number 13. As observed from the top of a 75-meter high lighthouse from the sea level, the angles of the depression of the two ships are 30 degree and 45 degree. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. So this is the question. Let's observe the question. This question is talking about a lighthouse of height 75 meter. And from the top of the lighthouse, an observer has observed two ships in the sea. We are having two ships in the sea, one behind the other. It means the observer is looking down toward the two ships from the top of the lighthouse. Angle of depression when we are looking downward, and this angle is with respect to the horizontal line. So these two angles are the angle of depression, which are 30 degree and 45 degree. Further in the question, we have to find the distance between the two ships. This distance we have to find in the question. So this is the question. Let's see how we approach the question. A point that you should note is that whenever we are having a question with angle of depression, The angle of depression are formed at the top point as we are looking downward. So these angles are formed at the top point. Somehow we have to transfer the angle from the top portion to the bottom portion because our triangles are formed at the bottom portion. So whenever we are having the case of angle of depression, we have to transfer the angle from the top to the bottom triangles. How we will do that? We will take the help of the transversals. Transversals and the parallel line, the concept you must have done in the previous classes. We will use the concept of transversal in which the alternate angles will be equal to each other in case of the parallel line. As we will take down the question in detail, you will understand it more. Okay, so let's approach the question. Let's give the name to the various points as A, B, C, D and P. AD is the height of the lighthouse, which is given as 75 meters. Point C is the point of the first shape and point B is the point of second shape. Further, here are you able to observe the two triangles, the triangle ABD and the triangle ACD. Here in this triangle we do not know the trigonometric angle. So through the help of the transversals and the parallel line, we will find the trigonometric angles for both the triangles. Let's see. Here can we say BD and AP both are parallel to each other? BD and AP both are horizontal lines, so they will be parallel to each other. And can we say AB is the transversal? Let's take these three line segment out of the figure. Here AP and BD both are parallel to each other and AB is the transversal. And in case of transversal, the alternate angles are equal. So these two angles will be equal to each other. This angle is 30 degrees, so this angle will also be equal to 30 degrees. The simple concept of transversals we have used. Similarly, if we take the line AC as a transversal and AP and BD are the parallel line, can we say these two angles will be equal to each other, as these angles are the alternate angles in case of transversals. So we got this angle as also equal to 45 degree. Got it? Whenever you are having the question of angle of depression, you have to transfer the angle at the top to the bottom portion. The same we have done here. We have transferred the angle at the top to the bottom portion so that we can apply the trigonometric ratio in these triangles. So whenever you are having the angle of depression in the question, you have to apply the concept of the transversal and the alternate angle. Note that this is very important. Further, we got the trigonometric angle for both the triangle. For the triangle ABD, our trigonometric angle is 30 degree. And for the triangle ACD, our trigonometric angle is 45 degree. And in the question, we have to find the distance BC, that is the distance between the two shapes. So the strategy that we will use is, firstly, we will take the triangle ABD and we will find the distance BD, the complete length BD. Then we will take the triangle ACD and we will calculate the distance CD. And BD minus CD will be equal to BC. Got it? This is the approach that we will use to find the distance BC or the distance between the two shapes. So let's take the triangle one by one. Firstly, let's take the triangle ACD. Here AD is the perpendicular as it is opposite to the trigonometric angle, and CD is the base for this triangle as this is the side between the trigonometric angle and 90 degree angle. So which trigonometric ratio will be applicable, or which trigonometric ratio is the linking between the perpendicular and the base? It is tan theta. So here tan theta will be applicable, which is equal to perpendicular upon base. So tan 45 is equal to AD upon CD. And AD it is given as 75 meters and the value of tan 45 degree we know it is 1. So we got CD as equal to 75 meter. Got it? We got the CD, the base of this triangle, the one component. Let's go to the second triangle, the triangle ABD. Here our trigonometric angle is 30 degree and AD is the perpendicular, which is the side opposite to trigonometric angle, and BD is the base, which is the side between the trigonometric angle and the 90 degree angle. Here also tan theta will be applicable, which will link the perpendicular with the base. So tan theta is equal to perpendicular upon base. Tan 30 degree is equal to AD upon BD, and AD it is 75 meter, that is given in the question. And what is the value of tan 30 degree? It is 1 by root 3. So on solving, we got BD as equal to 75 root 3. Got it? We got the base of this triangle. So we got CD from the first triangle as 75 meter and BD from the second triangle as 75 root 3. And in the question we have to find BC, which is equal to BD minus CD, which is 75 root 3 minus 75. So we got our answer, that is BC as 75 into root 3 minus 1 meters. That is the answer of the question. Got it? The better you are able to visualize, the better you will be able to solve the question. Here the learning that you got from this question is that whenever you are having the angle of depression, the concept of transversals and the parallel line will be used. So we have done with the question number 13. Let's move to question number 14. Question number 14. A 1.2 meter tall girl spots a balloon moving with a wind in a horizontal line at a height of 88.2 meters from the ground. The angle of elevation of the balloon from the eyes of the girl at any instant is 60 degrees. After some time, the angle of elevation reduces to 30 degrees. Find the distance traveled by the balloon during the interval. So this is the question. Let's observe the question. In the question, a 1.2 meter tall girl is given and she is observing a balloon in the sky. A balloon is traveling in the sky and at a certain point she has observed the balloon in the sky. The angle of elevation found is 60 degrees. Angle of elevation is the angle between the line of sight and the horizontal line. The girl is looking at the balloon, so this is the angle of elevation which is given as 60 degrees. The balloon is flying at a height of 88.2 meter from the ground and the height of the girl is 1.2 meter. Further, after some time the balloon has traveled some of the distance and now again the girl is looking at the balloon. Now the angle of elevation has been changed to 30 degree. Initially at the first point the angle of elevation is 60 degree. After some time balloon has traveled the distance. Now the angle of elevation has been reduced to 30 degree. Got it? This is the scenario. And in this question we have to find the distance traveled by the balloon. That is the distance between these 2 points. Okay. So this is the scenario given in the question. Here let's mark the different points as A, B, C, D, E, F and G. These are the different points. Here are you able to observe the different triangles in the given figure? These two triangles are the right angle triangle in the given figure. Firstly the triangle ABE and the second is the triangle ACD. These are the two right angle triangles. Here the height of the girl is given as 1.2 meter and the balloons are flying at a distance of 88.2 meter. So can we say this distance is 88.2 meter minus 1.2 meter? It will be 87 meter. So these two distances BE and CD will be equal to 87 meters. That are also the side of these two triangles. And further we have to find the distance BC. So the approach that we will use is from the triangle ACD we will find AC, the side of the triangle, and from the triangle ABE we will find the side AB, and AC minus AB will be equal to BC. That is the distance that we are looking for. So this approach we will use. For that we have to apply the trigonometric ratio formula in both the triangle. Firstly let's take the triangle ABE, this triangle. Here the trigonometric angle is 60 degree and BE is the perpendicular opposite to trigonometric angle and AB is the base of this triangle. So which trigonometric ratio will be applicable here? Here tan theta will be applicable as perpendicular and base are coming into the picture. So tan theta is equal to perpendicular upon base. Tan 60 degree is equal to BE upon AB. And BE we have just calculated as 87 meter. And what is the value of tan 60 degree? It is root 3. So we got AB as 87 upon root 3 meter. We got one part of the question, that is AB is equal to 87 upon root 3 meters. Further, let's take the second triangle, the triangle ACD. Here the perpendicular is CD, which is the side opposite to a trigonometric angle 30 degree, and AC is the base of this triangle. Here again tan theta will be applicable, which is perpendicular upon base. So tan 30 degree is equal to CD upon AC, and CD it is given as 87 meter that we have just calculated. And what is the value of tan 30 degree? Think it is 1 upon root 3. So we got 1 upon root 3 is equal to 87 upon AC. We got AC as 87 root 3 meters. Again, you should know the trigonometric ratio values for tan 30 degree, tan 45 degree and tan 60 degree. 90% of the time, these three trigonometric ratios will be applicable. It does not mean you should skip the other trigonometric ratio values. You should know the complete trigonometric ratio table. Okay. So we got AC as 87 root 3 meters and AB as 87 upon root 3 meters. And in this question, we have to find BC, which is equal to AC minus AB. Let's put the value. Let's take root 3 as the LCM. On solving, we got the answer as 174 upon root 3. We can further solve this. Let's multiply the numerator and denominator by root 3. On solving, we got our answer as 58 root 3. So we got the distance traveled by the balloon is 58 root 3 meters. That is the answer of this question. So we have done with the question number 14. Let's move to question number 15. Question number 15 is, a straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at an angle of depression of 30 degree, which is approaching the foot of the tower with a uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degree. Find the time taken by the car to reach the foot of the tower from this point. So let's observe the question. In this question, a tower is given on the highway. Let's have a tower. On the top of the tower, the man is observing the road. A car is coming toward the tower. That man is also observing this car. The angle of depression formed is 30 degree. Angle of depression when we are looking downward, this man is looking downward toward the car, and this angle is with respect to the horizontal line. So this angle is 30 degree when this man is looking from the top of the tower to the car at the road. Further, after a 6-second gap, the car has moved toward the tower. Now the angle of depression has been changed to 60 degree. Initially the angle of depression is 30 degree. After 6 seconds, car has traveled some distance. Now the angle of depression has been changed to 60 degree. And in this question, we have to find the time taken by the car to reach the foot of the tower. So basically we have to calculate the time this car will take from this point to this point. Let's take the various points as A, B, C, D and E. Here we have to calculate the time that we will take at the end of the question. Firstly, let's apply the trigonometric fundamental. Here the angle of depression is given, angle of depression when we are looking downward, and this angle is with respect to the horizontal line. Don't confuse it with the vertical line, a common mistake done by the students. So here 30 degree and 60 degree are the angle of depression. And here we have to transfer these angles to the bottom part of the figure. How we will do that? We will use the same fundamental that we have done for the previous questions related to the angle of depression. We will use the transversals and the parallel line concept. Here AE and BD are the two horizontal lines, so these two lines will be parallel to each other. If we take AB as a transversal, can we say these two angles are equal to each other? Yes, if AB is the transversal and AE and BD are the two parallel lines, these two angles are the alternate interior angle. So these two angles will be equal to each other in case of the parallel line and the transversal. So this angle is also equal to 30 degree. Similarly, if we take AC as a transversal and again AE and BD as a parallel line, these two angles will be equal to each other as these angles are alternate interior angles. Got it? So we got this angle as also equal to 60 degree. So we have applied the concept of transversals and the parallel line. Whenever you are having the angle of depression, you have to transfer the angle at the top to the bottom part, because at the bottom part we will have our triangles that you will see next. So you should note this concept every time. Whenever we are having the angle of depression, we have to apply this concept. Further, we got the two angles. Are you able to observe two right angle triangles in the figure? Here the triangle ACD is a right angle triangle and the triangle ABD is the right angle triangle. For the triangle ACD, our trigonometric angle is 60 degree, and for the triangle ABD, our trigonometric angle is 30 degree. Here if you observe, both the triangles are sharing the common side as AD. Here AD is common in both the triangle. So the approach that we will use is, we will apply the trigonometric ratio in both the triangle and we will find the distance AD or the side AD. As AD is equal in both the triangle, so we will find AD in both the triangle and equate the value of AD that we got after applying the trigonometric ratio formula. So basically we have to find AD in both the question, and after that you have to equate the value of AD. So this approach we will use in this question. Note that here no dimension is given. We do not know the height of the tower. We do not know the distance between the car or any of the side of the triangle. Only data that is given is the 30° and 60° angle and 6-second gap between the point B and C. Do not do the mistake of taking the 6 seconds as a distance. Here the distance between B and C we do not know. The distance between B and C is not given in the question. Only the time is given between the point B and C. The car has taken 6 seconds to reach from B to C. This is 6 seconds. Second is the unit of time, not the distance. So don't be confused with this. Okay. And in this question, we have to calculate the time taken by the car from point C to point D. That is again in the unit second, not in the meter or in the distance term. So this you should observe. Okay. So let's take the triangle ABD and let's apply the trigonometric ratio formula. Here AD is the perpendicular as it is opposite to our trigonometric angle 30° and BD is the base as it is between our trigonometric angle and 90° angle. So here we will apply the trigonometric ratio of tan theta. Why? Because here perpendicular and base are coming into the picture. And the only trigonometric ratio that link perpendicular and the base, it is tan theta. That is tan theta is equal to perpendicular upon base. So we got tan 30° is equal to AD upon BD. And what is the value of tan 30°? This you should know, it is 1 upon root 3. So on solving, we got AD is equal to BD upon root 3. Got it? We got the value of AD. Further, let's also find the value of AD from the second triangle, that is from the triangle ACD. Here AD is a perpendicular and CD is the base. So again tan theta will be applicable, that is perpendicular upon base. Tan 60° is equal to AD upon CD. And what is the value of tan 60°? Think, it is root 3. So let's solve for AD. We got AD as CD root 3. From the first triangle, we got AD as BD upon root 3. From the second triangle, we got AD as CD root 3. So let's equate both the values. We got BD upon root 3 is equal to CD root 3. On solving, we got BD is equal to 3 times CD. Further, if you observe the figure, here BD is this complete distance, which is composed of two parts, BC and CD. So we can replace BD with BC plus CD. On solving, we got 2CD is equal to BC. That is, BC is 2 times of CD. Further, in the question it is given the time taken by the car to travel from point B to C, it is 6 seconds, and we have to calculate the time taken by the car to reach from point C to D. Here we got BC is twice of CD, or we can say CD is half of BC. If the car is taking 6 seconds to reach from point B to C, then how much time it will take to reach from C to D? It will take half of the time. Got it? CD is half of BC. If the car is taking 6 seconds from reaching B to C, it will take half of that time to reach from C to D. That will be 3 seconds. 6 by 2, that is 3 seconds. But here we will not go by logic. We will apply some mathematical formula. The formula is speed is equal to distance upon time. This is a basic formula of speed that you must be knowing. Speed is expressed in kilometer per hour. Kilometer is a distance and hour is a time. So you must be knowing speed is equal to distance upon time. This is a basic formula that will be applicable here. From this formula, we got time is equal to distance upon speed. We have done so because in the question we have to find the time taken by the car to travel the distance CD. This is the basic formula, do not worry, only the basic formula we are using, no special high-fi formula we are going for. This is very simple, just pay your attention please, okay? If we take the distance BC, we can use time is equal to distance upon speed formula. Time, it is given as 6 seconds for the car to travel from B to C, that is distance BC. Here distance is BC, let's take it as BC. And what is the speed that the car has traveled? It is not given in the question, but in the question it is given the car has traveled with the uniform speed. So let's take the speed as S, just as the uniform speed. Here we can rewrite this as BC is equal to 6S. Further, let's also apply the same formula of time in the distance CD. Time is equal to distance upon speed. Let's take the time as t, the time that we have to calculate, and the distance as CD. And what is the speed? The speed of the car is uniform from the point B to D. The speed at which the car is traveling from B to C is the same speed at which the car is traveling from C to D. So again the speed will be S, the same speed that we have used in the first case. Okay. Here can we replace CD with BC upon 2? We have used this equation, 2 times CD is equal to BC, or CD is equal to BC upon 2. Further, we can also replace BC with 6S from this equation. Here S and S will cancel out, that is the speed is uniform, that is the helpful hint given in the question. S and S, that is the uniform speed, will cancel out. We got our answer as 3 seconds. 6 upon 2, that is 3 seconds. So that is the answer of the question. So you must also know some of the basic formulas of speed, distance and time. The basic formula you must be knowing to solve this question. We have not done anything special. We have simply applied the basic speed distance formula. Okay, so we have done with the question number 15. So students, we have done with this lecture. Hope you have enjoyed our new and creative way of teaching. If so, like the hit button, subscribe to our YouTube channel and also share this video with your friend. And do not forget to download the PDF of the concept and the formula list, and also check the link to the quiz in the description. So that's it for this video. Thank you very much for being with CREATA Classes. Bye for now. Best of luck and have a great day.